Alright, so this is going to be a longer video. It's just going to be me going over my lab projects for my computer science course, because tomorrow I'll be getting tested on my knowledge. Just there is a test basically to make sure that I'm the one who made the code. So I'm just going to go over it in this video. This is mainly for me, so I don't expect anyone to watch it. First things first, we're going to go into the actual class. And 174. So 174 is the introductory Python course. And the very first one is this memory game, not this memory game. What's this? Here's my test. Alright, two-dimensional grid. So the main gist of this is basically we have a text file that has numbers in it. So actually, let me pull up where that is. Where are you here? So we have these text files with data in it, and the data is going to be just lines 3, and each of these lines are going to correspond to a house price. Actually, okay. The very first line is the number of rows in the grid, and the second one is the number of columns in the grid, and then these are going to be the actual values in the grid. So they want us to make a grid with these dimensions, and then put these kind of in that grid. So this will be one row, this will be another row, this will be the second row, and this third row. So the caveat is that there's going to be these 0 points. And the 0 points, we don't want the 0 points. So we have these house prices, but we want to get rid of these 0 points. To get rid of these 0 points, we have to get the average of all its surrounding cell blocks. So that'll be this one, this one, this one, this one, and then for this one it's this one, this one, and this one, and so on and so forth. So this includes diagonals as well. And so this price is going to be average of all of these houses, and this is going to be the average of all of these houses. So you get the point. So our job is to calculate a new grid with these ones kind of filled in. And then after that, a realtor also wants to know the average housing in an area and the maximum house price. So we get these cells, and then we want to make these grids. And this is kind of, we want to create this grid. In Python they call this a matrix. It's basically a loop within a loop. So it's a nested for loop. So we're learning how to use nested for loops. So let's go into the code here. It's not a memory game, it's a grid game. I called it a game, but so yeah, I have these 4 data text files. What do I have for this exam.py? Anyways, so it's gonna be in the grid.py, and I just have this blurb in the beginning. I should probably change it, like probably delete those challenges. Okay, so the very first thing that you can probably notice is that I have these type hints. I was just playing around with type hints. I didn't need type hints. I probably won't continue using type hints. It doesn't look that clean. Like I think it looks clean, but at the same time it doesn't. I don't know. I don't know if I should keep type hints. So actually, let's go to the main program and then go from there. So what this does is, first of all, we have to create a grid. So the grid is going to be a nested for loop that takes in data from a text file. So this is like our sample one stata2.txt. So to create the grid, we first need to open up the file and read the information. So this is what this function does: is it takes a file name and then puts each line into a list. Puts each line into a list and returns that list. So this is going to be like a list of all those numbers, and then you have to create the grid. So the caveat in this is that, like we said before, in the data text files, the first 2 numbers are going to be the number of columns, number of rows. So the number of rows is going to be the very first number in that list that we got from up here. And then after that, the second one's going to be the number of columns. So we kind of just assign those values. And then where we're actually starting the data is going to be the second position. So what we want to do, so this is actually different from how they did it in the lab. I'm lagging over here. Give me a second. Oop, oop. Yeah, so this is actually different than how they did it in the lab. But basically what I did was I took a, I had this, I basically started on 2, and then after that continuously took out or popped out the number from 2 and appended it to this row in this loop. And then after that it'll continue until there's basically no more until there's no more, like until 9 is finished. And I'm assuming that because they gave us 3 columns and 3 rows, that they gave us 9 subsequent values, and then so on and so forth. So if this is 4 and 3, then they'll give us 12 values. So I didn't really need to worry about going out of range. But basically I started here and then I just popped this out. Now 8001, like, and then now this number is the second position, pop this out. Now this one is the second position, pop this out, and then we append it to these rows, and then these rows we append it to this grid. So then we'll have a list of lists of basically a matrix. So that's what this create grid does. And then after that we have to display our grid. So let's go down here. Where are we? Display grid. So display grid basically says what it does. It prints out the grid on the screen. The only problem is that our list of lists is just one single line, so it won't print out all neat like what this is. Okay, it'll print out like just one continuous line. So what we want to do is to go through every cell, or let's say this for row index and range length of grid. Yeah, so literally go through every cell in the grid and then round it. So we want to round it because they're float numbers in the beginning, so we round them to turn into integers so it looks cleaner. And then we want to print out each row. So that's where this end comes in. So basically what this is, it prints out the value of the data cell, so let's say like 9400 with these pipes in between. And then after that, end equals to nothing, basically. An empty string basically means that don't line break. So if a whole, so we'll continuously, so this prints out everything in one column. So everything, this prints out a whole row basically. So this will go like 9400, like it'll basically print out this one without going like, without line breaking at all. That's what this end does. And then what this is for is to line break. So after it finishes printing every single data in one row like this, then at the end of this, then it'll print out that row, it'll line break that row in the end. So I could also have done this because the default option for print is going to be a line break, but I had this just for better clarity. If they ask me, then you know this is what actually is happening, and this is how I'm doing it. So cell exists basically. Okay, and then we have this find neighbors value. So why do we need find neighbors? Because we need a newly calculated grid. We need to fill in these zeros, right? So oh shit. Nope. So the rationale to fill in these zeros is to get these neighbors. The only problem is that the maximum amount of neighbors is 8, and the minimum amount of neighbors is, I think, 3 or 2. So basically, it's variable. So we need to know if a cell exists in the first place, because for the 0, the cell on top of it doesn't exist, and that's still adjacent. The cell diagonal here doesn't exist. The cell diagonal here doesn't exist. So we have to make sure that when we're targeting a cell, these adjacent cells exist for us to calculate the average of. So that's where these boundaries come from. So row index is less than or equal to row length, and row index is bigger than or equal to 0. So basically, it just means that it has to be smaller. It has to be smaller than out of bounds over here, so it has to be smaller than this, and it has to be bigger than 0. And then after that we have the column boundaries, so it has to be this is the column boundary. This is the up down is a row boundary. So what I just said was a column boundary, and then the row boundary basically has to be less than down here and has to be bigger than up here, which up here is 0. And if it suits those categories, then that means the cell exists. And then this returns a true or false statement. So this one is the one that I'm pretty proud of here. Basically, I put every single check, because like basically to check the neighbors, we have to check the verticals, we have to check the horizontals, and then we also have to check the diagonals. So I put each one into a tuple. So the top data is going to be the row index. So this is a row, this is 1 row, this is 2 row, this is 3 row, and these are the columns. 1 column, 2 column, 3 column. So the data on the top is going to be whatever row that we're targeting, or whatever cell we're targeting, the data top is going to be the row minus 1. It's going to be the same column but row minus 1. And then for data bot, it's going to be the same. It's going to be the same column but a row plus 1. So it's going to be the data bottom. And then on the other hand, the check horizontal is going to be the same thing, but with a column index that's plus or minus 1. And then for the diagonal, it's kind of similar. It's going to be row index for the top left, row index minus 1, column index minus 1, kind of like right here. So that's going to be I'll just do this one for example. So let's go 290. Row index minus 1 is up here, and then column index 1 is minus here. So this is going to be where that cell is. And if you notice here, I have the data tuple, like the cell exists function takes in a tuple as a parameter, and the tuple parameter is the row index and the column index, which we have over here is the data tuple is the row index and column index. So basically, we just have to loop through every single value in this overall data tuple tuple. And check to see if each one of these exists, and if they do exist, then we append that value that we have. So like 0, top doesn't exist, so we don't append anything. Diagonal doesn't exist, so we just append it. And then it was 30,000 exists, so we append that to a list, and then we'll get a list of neighboring cells, and that's going to be this neighbor list. And then after that, what we have to do is fill in the zeros. So that's what this fill gaps is it for. Let's see, so this just takes a copy of the grid because we don't want to mess around with the actual grid itself. To a coordinate 0 list. So okay, the very first thing we need to do is find zeros in our list, right? So this basically looks at every single cell in the grid, and then sees like, oh, if it's a 0, then we'll put that into a tuple of its coordinates. So we put that to 0. So we put a list of tuples of the 0 coordinates. And then after that, we just say we just take out the coordinates from there, from the tuple in the 0 list, and then we just find their neighbors. We get the average of those neighbors, so that from this get list average, and it's basically just a function that gets the average of of numbers in a list. And what the fuck did I do here? Okay. And then after that, it fills it in. So filled grid, row index, column index. Where's this filled grid? Oh yeah, filled grid is basically just the same thing as this. It's just a copy of the grid, and then the 0, we replace it with the average, and then we return the filled grid. So we return the filled grid that is down here. So grid is equal to create grid, and then filled grid is equal to filled gaps, and then after that we display that filled gaps, print it out, and then after that print out the maximum average and the average of the area, and then the maximum housing prices. So that's pretty simple. We just find the maximum, or we find to find the maximum, we just start at the lowest possible value 0, and then if there's any, and then we loop through every single value. And if there's a number bigger than the max value, then the max value is now that number. And then finding the average is pretty similar to the other one. Yeah, it's not that it's pretty simple there. And yeah, that's that. So that's the grid game. That's 15 minutes of talking. Holy moly. Okay, and next is gonna be my memory game. So the memory game is, if you remember like the matching games you've had as a child. So actually, what I'll do is what I didn't do before is test out the game, test out the grid game. So let's p grid game. Actually, I'll do that again. So yeah, so we start off with this grid, and if everything works correctly, then all of these zeros will get replaced by the average of its neighbors, and then it finds the average housing price and the maximum housing price. So we know that works. Like it's a working code. We have this memory game. So the gist of the memory game. So I won't actually go into the document here, but the gist of the memory game is that we have to make a game that we're using Pygame that matches. That's like a matching game. I don't know if you know what a matching game is, but I'll demonstrate here. So this is what a matching game is. Basically, click, and you want to match the tiles to a tile that matches. So this matches, and then it kind of stays open, and then we have this counter in the top right. And if you don't select the right tiles, then it kind of reverts back after 0.5 seconds. I like 0.5 seconds because it's fast. I don't want to wait too long. So let's quickly finish this. Here, and there. And then after that, it prints out the success. Okay, so let's look into this code. And the code was based off of a framework that was provided for us in class, but a lot of the functions was something I implemented. So, I'll just go through everything. This will probably take like half an hour, but this pygame.init function basically initializes everything. Set mode is the width and the height of the screen that we just played. Set captions memory. So I have tiling set on to hide these top the top bar, but if the top bar was open, it would save memory on the top to get the surface. So this is just to allow us to actually write things onto the surface of the screen. This is to create the game object or the game class, and then after that, this is one of the functions that plays the game itself, and then quit. So if you look at the play game function here, play game a function, those are all these things, either until we close the game, or if the game kind of the continue game is false. So if the end game condition is met. So we can actually go through each of these. Okay. So in the very beginning, what I had to do was to get the images. So the images that we used to play or start the memory game, I had to get those images. And I wanted to be fancy, so I was using a for loop instead of actually getting them one by one. So I just use this for loop to append, because the images go from image 0.bmp, image 1.bmp, image 2.bmp. So I just appended a bunch of strings with counting from 0 to 8, I believe, yeah, 0 to 8, and then put them into self.images. Or it was 1 to 8, yeah, 1 to 8. 0 was the hidden image. So 1 to 8, and then I concatenated them with themselves. So I kind of doubled it so that I can get 2 images because we want pairs, and then I shuffled them because we want a different game each time. And then we have to create the board. So similar to the grid game, we have to make a list of lists, but instead of integers, these are going to be a list of objects instead of list of integers. And that's going to be the tile class that we create in the bottom. Okay, so actually, I will close this and key memory game. Okay, so I'll just have this running in the background. So we when we were given the example for this, I already noticed that this was actually 1, 2, 3, 4, 5 columns over here. But this whole entire column was blank so that I could have this this update or score function. So the very first thing I was like, okay, so this is actually instead of a 4x4, this is like a 5x4, and that's why I had the board width as 5 and the board height as 4. And then I just had to figure out a way to not make these tiles in this last column right here. And so that's easily solvable with an if statement. So I made a nested for loop, or like a for loop inside of a for loop, to create a nested list. And basically said if the column index is not equal to the very last column, then create the tiles. Otherwise, we don't create this tile. So that kind of leaves a blank column at the last column. And then the self.hidden image is one of the parameters that we have for this tile, and that's going to be this question mark. And then the and then this one is the exposed image, which is going to be this. So that's this exposed image. Okay, and then after that, we just append that into a list of lists. Yeah. And play the game. We already talked about that. Handle events. So handle events basically runs every single time anything happens in when we're playing the game. So if we're clicking, if we're typing something, handle events will run. And this basically wants to this function allows us to interact with the events of the Pygame. So we only have 2 events here. One of them is the pygame.quit. So you know what? I'll just if I turn off tiling here, am I done? Oh, here it is. Show window tiles. So yeah. So basically, this is if event is equal to pygame.quit. So if I click this quit button, then it'll close the Pygame. And then this second event is going to be mouse button up. So if I click, and then after I move my mouse unclicks itself, something will happen. And you already saw like the functioning of that was to unflip or to flip this card basically. And this and self.continue game is just to make sure that no events run when the game is over. So like that was that success screen. So making sure that the score stops and everything stops once that game was over. And so this mouse button up calls this other function called handle mouse up. And basically what this does is it goes through every single tile. And it makes sure that, so this self.click tile is really important. So this is a list that I created that basically makes sure that there's only that we're only allowed to click 2 tiles. So we click one tile. If we click one tile, so this is actually self.add tile. Once we click a tile, self.add tile will run, and this will append the tile that we clicked into a list called clicked tile. And this basically makes sure that as long as we've only clicked 2 tiles so far, then we'll be able to click other tiles. Otherwise, we can't click. So let's say we click on this, and then we click on this, and then we try to click on something else really quickly. We won't be able to do that. We will only allow a maximum of clicking of 2 tiles, and that kind of helps with bugging. And then we have this tile.select select. So tile.select is also pretty important. It just makes sure that we selected a tile. And how we do that is using the collide point method. So these tiles are in Pygame are recognized as a rectangle, and rectangles have this inner function in Pygame called collide point. And it basically detects, or it basically returns true if a single point collides with the rectangle that we're on. So it takes a position as a parameter, and then after that it says like if this position collides with that tile that we clicked on, then it returns true, and otherwise we return false. And this is basically making sure that self.hidden tile is the content is equal to the exposed tile. So if I let's find one. where here. So let's say like we can flip this, right? But if this is already exposed, if it's not a hidden tile, and we click it, nothing happens. So that's what that does. Okay, so let's go to handle mouse event. So that's what this happens. Click tiles -2. So you might be asking, okay, well, like we append this tile, but then how do we keep on having less than 2 each time? Like the more we click, the more we append, right? And that actually happens in this update function. So in this update function, what it does is, as long as we've clicked, if self.click tile, so if that list has more than 2 lists, or if it has 2 or more actually, then it'll run. Update tiles runs every frame. It'll run, and then it'll be like, okay, is the first tile, is this tile, like, if the first click tile is equal to the second click tile, is it? And then it'll see if it is, and if it is, then it won't flip it back. It won't reset it, and it'll keep it open. Otherwise, if it isn't, if this is incorrect, so this is incorrect, if this is incorrect, if that's incorrect, it'll flip the card back. It'll flip the card back, and then this self.reset tile check will reset the list, basically. So that's how it goes from being 2 tiles on the list back to 0 tiles on the list. So that's really important. So yeah, click tile.clears basically just clears the list. Yeah, and then okay, so we have this draw method. Draw basically writes the rectangles onto the screen so that we can see it. So yeah, so for every tile we draw it. For the score, we draw the score, and then after that, if not self.continue game, so if the game is over, then we draw the end tile, which in the very beginning you saw was that success. And then pygame.display.updates, what is this? Makes the update surface appear in the display. Okay. Oh, and then, oh yeah, did you see that? That was my automatic wallpaper switcher. And this just draws the score on the very top right. So top right is basically the width of this whole entire box minus the width of this number, and it'll allow it to go on the top right corner. Yeah, because it starts here. It starts top left. Yeah, it starts top left. So this is the point actually right here. This is the point that we use to draw. Draw and title, I put it right in the middle. Update, I talked about updates, update tiles, reset tile check. Decide continue. So decide continue is pretty unique, I want to say. Basically what it does is it constantly looks through, so every single frame, it looks through every single tile. Every single frame, it looks through every tile, and it checks to see, is all the tiles exposed? If all the tiles is exposed, then we end the game. Otherwise, we continue the game. So it's continuously kind of checking this in the background. And we have this tile object. So like I said before, we have this these parameters. These are just the dimensions. The surface is how we're actually going to write to, and then hidden and exposed tile. So select, we already talked about. Get exposed tile and get tile content is pretty self-explanatory. The flipped card, basically, if the tile is exposed, then we make it a hidden tile again. Otherwise, if it's a hidden tile, then we make it exposed. So that's how we have this switching effect. Draw draws the content, and then blitz is a pretty unique function where that's how we actually put like these numbers and these images onto the screen, is to blit it. I'm pretty sure like to put images on, we have to blit it. Yeah, so that is that game. That was 30 minutes of talking about my I think hopefully I get 100% on this, because I fucking doc string the shit out of this. So yeah, good night.